Okay, recording is started. Welcome to the March, it's not the March 21 edition, it's the April 4 edition. Let's fix that. Okay, April 4th, 2013. Welcome to the April 4th study hall. We have some more flexibility in problem solving remaining from last time. We also have passages with statistical measures in critical reasoning. So we've already gone over the rules. The rules are the rules. And so when there are multiple choice questions, again, please use the multiple choice options that are underneath your name in the Illuminate window, whatever it is. And keep in mind that this is the GMAT. This is an exam on which you have to answer every question in the order that you get the questions. So please don't forget that. Other than that, let's go ahead and jump into this. So here's a problem. I'll give you a timer for this problem. Here's a timer. And remember where you find the answers to multiple choice items. Those are found here. Go for it. Okay, there are lots of non-responses to this problem, like lots and lots and lots of them. As in more than half the people here still haven't answered it yet. So please pick a multiple choice response. Again, this is the GMAT. The GMAT is a test where you can't not pick a response. So make sure you pick an answer to the problem just to get yourself into the rhythm of things in the next, say, 10 or 15 seconds. Okay. Let's see. All right, we still have a decent amount of someone saying I didn't see the question. It's on the screen. I mean, we got 50 other people who are seeing it, so maybe that's a tech problem on your end of some kind. Let's see. The two people who didn't see the question, both of you guys have some kind of cell phone icon next to your name, so maybe you're seeing this on some mobile device or something. But you should. I don't think that should be a problem. But both of you guys appear to be on cell phones. So anyway, I mean, there's a problem on the board, and we got 48 people who can see it, so we got to discuss it here. Here are your responses as a class. So we seem to have a strong preference for D and E here. But let's take a look. Does anybody know a way to solve this problem that isn't algebra? Like where you don't have to manipulate a bunch of pi's and r's and things like that. If you do, go ahead and let me know in the chat box. Yeah, you could throw a number in. And I like the idea especially that Ben is putting there. You can go ahead and use 0 if you are really lazy about things. So sure. Definitely throw a number in. So I mean, make sure you know we have a name for this in our materials. We call it VIC, which stands for, I mean, we actually have 2 names for the same concept. So let me tell you what those are. In our materials, we call those things VIC or smart numbers. The VIC stands for variables in choices. So that's what we would call this in the book, because there are variables in the choices. Smart numbers is exactly the same idea. It's just that it's just different in the sense that they don't have variable names. But if you see the ideas of Vic and smart numbers in the book, those are basically the same thing. So the point here, again, if you haven't seen this method or if you're not super familiar with it, the idea is that R, we don't ever find out what R is in this problem. You don't have to, you don't find out the value of R in this problem. So you can just pick it yourself, is the point. So as far as what value do you want to pick, well, let's talk about this suggestion right here. Because the thing is, the point of this method is to streamline the process. The point is to make it easier to work the problem and to let you circumvent algebra and circumvent, all these other sort of uncomfortable calculations or whatever. So this is actually not a bad suggestion right here. Like, let's go ahead and use a radius of 0 for R. I mean, because that is legitimate. I mean, that is a case. That is a thing. So it should work if you use a radius of 0. So let's just use R equals 0. Because if R is anything but 0, then you run into this problem of bad numbers, right? Like if R is if R was 2 meters, then you'd have to use 4 pi meters to make the circle, and then you would have like 40 minus 4 pi left over to make the square. So you're going to have some ugliness. But if R is 0, you don't have that ugliness. So if the radius is 0, then, well, the circle, which the quote circle unquote is just a single point with quote radius unquote equal to 0. It's just a dot. It has no size. So that's our circle. It uses 0 meters of wire. And so how much wire do we have left to make the square? At 40, right? So this will give us 40 meters of it's the whole 40 meters that you started with, 40 meters of wire with which to make the square. So if you make a square with 40 meters of wire, then I think we know what that's going to look like. It's going to be 10 by 10 by 10 by 10. You can just do the mental math on that one. So it's a square. You can't be like 15 by 5 because then it wouldn't be a square. So it has to be 10 by 10. And so the area that you're looking at, I mean, that thing on the left has no area. This has a 0 area. So your total area is just the area of that, which is 100 square meters. So let's see how that does. But again, you gotta have a goal. Make sure you know what it is that you're finding. In this case, you're finding the total area of the circular and square region. So, okay, total area is 100 square meters in this case. Total is 100 square meters. What do we do with the answer choices? I mean, the answer choices don't say 100 square meters. They have like random expressions of pi and r everywhere. So, who can tell me what we do with those? Yeah, you take the same thing you plugged, right? 'Cause that's the point of this method, is that r is not r anymore. At least for the moment, r is 0. So if you plug into these, well, that is just 0 in choice A. This is 0 plus 10, which is not 100. This is 0 plus another 0. So 0 is not 100. This is 0 plus 40 squared, So 40 squared, even if you don't know what that is right away, that's much greater than 100. And then this is 0 plus 10 minus 0 squared, so that's 10 squared. And that's 100. So there it is. Only E works. I mean, what's interesting about picking a number like 0 is that you do have this huge possibility of coincidence. But here that didn't even happen. You plugged in the nicest number you could think of, and you still got one correct answer. So, I mean, Jason, it would work if you did that. It would just, the numbers would not be as nice. Like if you picked R as 2, then you'd have a circle that would be 4 pi meters. Then you'd have 40 minus 4 pi meters left over. So this would be 10 minus pi, 10 minus pi, 10 minus pi, 10 minus pi. And then you'd have, it would still be this. And I'd encourage you to work that out at home, or, well, you're probably at home. I'd encourage you to work that out later and see how that works out. Any questions about this method? What do you guys think when you do this? Like, let's say that choice B gave me 100, or choice A, or one of the early choices gave me 100. Would I have to keep plugging into the other choices? Yes or no? Tell me in the chat box. If you get the answer you're looking for, do you have to keep plugging in? So yes, you do. You have to. Pete, I don't know what only if get 2 answer choices means. Ben says that's where the GMAT tries to trick you. It's not really a trick. In fact, one thing the GMAT doesn't really ever do is try to trick you. It's actually one of the nice things about the GMAT is there's no subterfuge. Like there's no stick your foot out and try to trip you up moments. Like the only things that really come close to that are like trap answers that get you if you're just not thinking. But that's not the same thing as trick. So no, you do have to keep plugging, and let's talk about why. Like if you plug in your own values, then you absolutely must check all the choices. Bar none, you have to do this. This is not optional. It is a thing that you have to do. I mean, the reason why is that when you plug in a number, you are only looking at one snapshot of a thing that has lots of possible snapshots. Like in other words, R is not just 0 in this problem. In this problem, R is a thing that can be any radius at all as long as it doesn't make the circle bigger than this. So R could be anything at all between like 0 and 20 over pi. So the point is, if you just look at one snapshot of that, it's like looking at a broken clock and a not broken clock, where if you look at them at exactly the right time of day, they might show the same time, even though one of them is broken. You know, in other words, like if I have a clock that's stuck on 9 o'clock, and if I have a clock that works, then if I am unlucky enough to look at those 2 clocks at exactly 9 o'clock, then I will not have any idea which clock is right. And that's the point. So, same sort of thing here. Here's a really stupid example, but it'll help get the point across. Which, the question, what is x plus x? Choice A, it's x squared. Choice B, it's 2x. Okay, so the answer to this is very clearly B. I mean, we know that x plus x is not x squared. There's no question that the answer here is B, but let's say that you were uncertain. Let's say that you were plugging in. I mean, you would not ever use plugging for a problem like this one. But let's say you plugged in 2, or 0, like Nova says. If you are unlucky enough to plug in 2, So if you do that, then you will get 4 for both of these, and your desired answer is also 4. So two things about that. The first is you can't eliminate with that choice. And if you stopped at A, at the first 4, you'd get the problem wrong. So that's why you have to check all the choices, because things like this can happen. And this is where I want to rope into this discussion that one commenter says right here. Okay, like this. On most other problems, we avoided plugging in values. Okay, so here's what someone has to say, and that ties into what's on this board right here. On most other problems, we avoided plugging in values such as 0 and 1. And I mean, it's true you did, and the reason why you avoided plugging those values is because those are more likely to lead to coincidences like these. I mean, you should not blindly memorize that you should not plug 0 or 1, because that's not a blanket rule. There are plenty of cases where plugging in 0 is not ill-advised at all, like the last problem. But the point is, if it's easy to plug in other numbers, because the point with things like 0 and 1 and so on is that they are very likely to give coincidences. Like, if you plug in 0 here, you'll get 0 and 0. You know, because 0 times 0 and 0 plus 0 are all 0. And 1 times 1 and 1 to the 1 and 1 to the any power is still 1. So you're more likely to get coincidental answers out of these. But the point is, if it's going to be really annoying to plug in other numbers, you should still start with 0 or 1 and take your chances. Because like the worst thing that could happen would be this. And this is not really that bad, because all you have to do is just plug in another number, which takes what, like, 5 seconds. Let's just say x is 5 or something. So then the answer is 10. So then A is not 10, and B is 10, and you're done. So, I mean, it's still a great method. Like, you will not, if you have to plug in another choice, then oh well. So the best way to think about this sort of thing is to say, well, if other numbers are easy enough to plug in, then yeah, don't pick 0 or 1. But if it would be super annoying to plug in other numbers, then go ahead and try the easy numbers first. Because remember that efficiency is your ultimate goal here. Like, more than anything else, you are trying to not waste a bunch of time. So, in this problem, anything but 0 will give you sort of annoying things with pi in them. So 0 is an excellent first thing to try, because it just makes the whole thing a square. And I mean, if there were more than one choice that gave you 100, then you would just deal with it at that point. So, okay. There's a question in the box that says, I keep getting these stupid hover boxes. What do you guys think about this question? Right there. Is there a magical go-to plug-in number? I mean, yeah, there's definitely no. And I mean, what I have to say is more general. I mean, you should, like, more generally, I don't like the mentality that this question reveals, Because if you're asking this question, then the implicit question, like the question that's part of this question, whether you're explicitly thinking about it or not, is like, can I just memorize some approach so that I don't have to think about the problem? Like, that's what this question really is. I mean, you might not have thought of it in that way, but that's the question. And if you have this sort of thing in mind, this is all bad news all day. I mean, this is a thinking test. If you try to memorize any set of approaches to this test, you will just you're in for a world of hurt. I mean, this is a test where you don't have to memorize almost anything at all. But the flip side of that is you have to be very quick with thinking on your feet. Like, you have to be an analytical thinker. You have to be able to feel out a situation and sort of understand what's going on. So there's not, I mean, no, there's no go-to numbers. I mean, the point more directly in response to this question is that you should tailor your numbers to the situation. I mean, you should pick appropriate numbers for the situation. So, for example, if you have, 1/3 of the socks in Stella's drawer are red and 1/5 of them are blue, well, then 1 would be an obviously terrible choice for the number of socks in Stella's drawer. I mean, the number of socks should be a multiple of 3 and 5, so that you get integer numbers of red and blue socks. So, I mean, 100 would also be a terrible choice of socks here, because then you would wind up with 33 and 1/3 socks that are red. So, I mean, some people are just like, oh, I should plug in 100 all the time. Well, no. Or like if blah, 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 X seconds, blah, 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 how many minutes, blah, 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 question mark. In this case, you probably don't want X to be like 5 or 10 or 1. I mean, in this case, X should be, 30 or 60 or 120 or some number that converts easily to minutes. So you basically, the point is you need to be playing heads-up ball here, is the point. You need to see what's going on in the game, and then you need to play the game. So that's the best way I can answer that question. So it is the flexibility section, so we're going to look at a more traditional solution to this thing, too. Here is the problem. Why is it? Are you serious? Okay. Let's look at an algebraic solution to this thing. Get it up on the board. That's interesting. It's not letting me copy and paste it. I think that's the issue. Okay. So here's the problem. All right, if you wanted to use algebra, you can certainly also do that. I mean, that's not really the point of today's session, so we're going to be sort of quick about that. But algebraic solution, sure. So you have a circle with radius r. And there, don't forget what your goal is. In this case, the goal is what's the total area of both. So what do we know about a circle with radius r? Tell me in the chat box. What do we know about that circle? Yeah, it's 2 pi r is the circumference, and the area is pi r squared, right? So the circumference is 2 pi r, and area is pi r squared. And I mean, how are we going to use each of these? Well, remember what your goal is, right? So this is a component of your total area, which that would help you eliminate acceptance in all 5 choices, so it doesn't. But, you know, at least heads up, right? And then how do you use the circumference? Well, the circumference is made from that wire. So how much wire do you have left over? Yeah, you have a total of 40, right? So you have 40 meters of wire total. So that's the sum of the 2 perimeters, because that's what the wire does. It makes the perimeter of each thing. So you have 40 minus 2 pi r left over to make your square with. So, I mean, this is not awful as far as the reasoning goes. It's just these expressions are just sort of icky and bulky. But, you know, it's the same sort of idea of here's how much rope we have left over. So that means that I mean, that's how much total perimeter you have. That means that each side of the square is 1/4 of that length. So that's 1/4 of 40 is 10, and 1/4 of 2 pi r is 1/2 pi r. And that's where this comes from. So this is the area of the square, is that thing right there. So but the point is you should be able to do this problem in both ways. You should be able to do it with the letters in it. And you should also be able to do it with throwing in a number. You don't necessarily have to throw in 0, although as you see here, plugging in 0 makes your life very friendly for a while. But you can the point is to be able to do it both ways. And I mean, as we've recapitulated in many of these sessions, that's really the only reason you're doing this. And remember, your primary goal of studying Quant is to find as many ways as you can to solve the problems. And especially ways that you don't like as much at first. Like, that's really the point. Like, because remember, there's no math to really learn on this test if you are scoring decently high or high. I mean, if you're scoring more than like mid-30s in math in the quant section, then you don't really need to learn any more mathematics, like at all. So what you need to learn is more strategies for problem solving. So like if you're already good at algebra and you're studying a bunch of algebra ways to do these problems, you probably will not get any better at the GMAT. But if you are very good at algebra and you incredibly intensely study things like plugging in your own values and back solving and stuff, that's where the extra points are going to come from. So just make sure you know that, because that's where the juice is here, basically. All right, there's one more comment on here I just wanted to address super quickly, which is this one. Someone wrote that 2 pi r had to be 20. Not really. Like, this implies that you're cutting that wire exactly in half, but there's no reason to assume this. Like, this assumes that you use exactly half the wire for each piece, and there's no reason to make that assumption. I mean, you could pick that if you wanted to pick numbers, but then that would be pretty bad. Like, you would wind up with a decent square, but a horrible circle. But you could do that. You could do, you know, a square with perimeter 20 and a circle with perimeter 20. But this does not have to be true. Okay, we are going to move on to another one of these problems. So, but again, you have the algebra method. You're welcome. And you have the not algebra method. And again, neither one of these is better than the other one. That's the other thing you should definitely get in your head, is that if something solves a problem, then it is just as good as anything else that solves the problem. So this is not in any way like worse than doing algebra. I mean, there's these weird emotional reactions people have to this, like, oh, in school I wouldn't have gotten credit for that, so people just don't like it. Make sure you get over that. This is not school, and getting credit for these things is not an issue here. So your point is just to solve the problems by hook or crook, by whatever means. Speaking of means, here's another problem. Give it a shot, clear your answers out. Here's another timer. Be a little bit shorter timer this time because it's a shorter problem. So go for it. Remember where to find multiple choice answer options. They are found here. They are not found. Please do not type in the chat box. Have fun. Okay, boys and girls, so time just expired a little while ago. Again, most of you haven't answered the problem yet, so this is not a long problem, so make sure you pick an answer of some type relatively soon here. And I mean, the other thing, a word, while you guys are still getting guesses up there, a word about time management. Remember what this test is. It's almost above all. It's a test of whether you can sort of pick your battles and manage time properly here. So, I mean, one point to make as far as that is concerned is like if you are still working after a decent amount of time. I mean, a decent amount of time depends on the problem. Like, if it's a really short problem, then a decent time might even be 30 seconds. But if it's a really long word problem, 2-3 minutes maybe. But if you're still working after a while, because one thing about GMAT problems is that they are not slow. Like, GMAT problems are all fast. That doesn't mean that they're easy. It just means that they're fast and they don't have a lot of steps. So if the point is that there should not really be a situation on the GMAT where you're like solidly working on a problem for more than like a minute or two. So, and I mean, a longer problem, you might take another minute or so to just get oriented with the problem, so maybe 3 minutes. But the point is that none of these problems are lots and lots and lots of work. And so if you find yourself doing lots and lots and lots of work, then at some point you need to check yourself. And as far as how should I check myself, so here are some guidelines. You should ask yourself the following questions. Do I know what I am doing? Do I know exactly what I'm doing? Do I know exactly why I'm doing it? And is it really going anywhere? And like, if the answers to these questions are not 3 solid yeses, yes, yes, and yes, then you should quit right now. This is really, 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 really important. In fact, this is probably the single most important thing you can know about the GMAT. If you are ever just sort of randomly pushing variables around a page with no purpose, then you should get out of there and just quit and just sort of throw that problem. Because remember, this is a test where it's perfectly okay to get a lot of problems wrong. And that's the nature of an adaptive test. You can miss lots and lots and lots of problems, and it's totally fine. So this is a big thing. I mean, there's a problem like this. This may not be easy for you. It may not be hard for you, like whatever. I mean, different people will think this is easy or not easy. But the point is, this problem is not slow. Like, if you're still working on this problem after like 2 minutes, then something is amiss. And you should try to be honest with yourself about that, just so that you don't run into this time sink problem. So, all right, here are your class responses. There are still, there's 57 people here, and I'm only counting about 38 or so responses. So that means that a lot of you guys are just not answering the problem. Please put some sort of answer to the problem. And remember, that's what you find here. I'll give you like 5 more seconds to do that. So here's where you find the multiple choice options again. Andre, please don't type in the chat box. As it says here, please select the responses where they are indicated here, not in the chat box. Okay, so it's no problem. Just yeah, just make sure that you are doing that. Okay, so here are your class responses. Put them on the board. So we have a decently strong majority on this problem, but still not a not a unanimous vote by any means. Let's take this to the next page. All right, here's your class results. It's being a little bit slow, pardon the delay. Okay, here's how we did. So we have a majority, it's not a majority, we have a majority of respondents liked A. But again, let me stress, there are definitely people who didn't answer the question. We all know what that means. It means that you're just not preparing for the test that you're actually going to take. So what's a way to do this problem that doesn't require you to do any algebra? Tell me in the chat box. No algebra solution. Yeah, start plugging answer choices. Sure. So that's really the thing, is just throw the answer choices in there and work backwards. So let's try that. Start from an answer choice and work backward. And I mean, what's interesting about this problem is the median doesn't ever change, because like these numbers are all in increasing order. Because like it would be more interesting if it was just 5, 4, 5, 6, 8, 10, and like random x that was not in increasing order, because then the median might be different. Like if x could be 2, then the median of the list would be 5.5. But if x could be bigger than these numbers, then it'll be 7. So, but they don't let you do that. It's not as interesting because x is always the biggest number. So the median is 7. But sure, let's just start with one of these choices. Let's say that one. What's interesting about this is that it's a little bit more efficient to start with B or D. All things equal, it's actually slightly more efficient to start with B or D than to start with C. This surprises a lot of people. Like, people want C to be the most efficient place to start because it's in the middle and it's very pretty to think about starting in the middle. It's a very nice concept that even like a 3rd grader would understand. But what's interesting is that if you start with B or D on these kinds of things, because the deal is, okay, like let's say you chose C to start with. Let me just give you a quick explanation of this statement. Like, if you start with C, then if the answer is anything but C, then you'll need to try 2 options. Right? Like if it's A or B, then like C will be too big, and then you'll have to, or in this case too small, and then you'd have to try A or B. And if C was too big, then it would be either D or E, but then you would have to try D or E. So in other words, unless it's actually C, you have to try twice. Now what's interesting about starting with B, and again, people would not think starting with B would be the winner here because, you know, it's not as conceptually pretty as starting with C. But when you start with B or D, if you start with B, if the answer is A or B, you only have to plug once. You only need one plug-in. I mean, that's what's nice about this. Like, if you plug in 15 and it's too small, then the answer is automatically 16. And if you plug in 15 and it works, then of course the answer is 15. So, and then if you don't, then if it's too big, then you would just plug in the middle of the remaining 3 choices. So starting with B is actually more efficient than starting with C. So let's try that. Let's try B. That means your list of measurements is 4, 5, 6, 8, 10, and 15. The median is 7. It's the average of 6 and 8, the 2 middle terms. So the average of 6 and 8 is 7. And then the median, the mean is the sum of all those things divided by 6. So the sum of those, 4 plus 6 is 10, plus 5 is 15, 23, 33, 48. So it's 48 over 6. So 8. Now notice that 8 is not 6, 7. I mean, 7 is not 6/7 of 8. So this is wrong, because this is what's supposed to happen. And then if it's actually 7/8 of it. Now, if you don't realize this right away, then you don't need to worry about it. But 7/8 is more than 6 over 7. Like, this means this is the ratio of median to mean. So if that ratio is too big, that means your mean is too small. If you realize that, then you are done, because the only thing that makes the mean bigger is choice A. But if you don't realize that, then you can just go ahead and try A. Like, that's the real point here. The point is not you have to have this insight right away. The point is that if you don't have this insight in like 4 seconds, then you should just throw in another choice and see what happens. So let's try A. So then you have 4, 5, 6, 8, 10, and 16. So then your median is still 7. And your mean is, the sum is 1 more, so now it's 49 over 6. I mean, if you want to make common denominator to compare these two, 7 is 42/6. So, and indeed, 42 is 6/7 of 49. So also likewise, 42/6 is 6/7 of 49/6. So the median is 6/7 of the mean. So there's your answer. Pete points out that sometimes you cannot do the big small thing at all. And Pete, of course, you are exactly right about that. But the point here is not to think about those. I mean, the point is, if you can do that, then here's what you can do. The point is not you can always do that. You know, like in some cases, you're absolutely right. If you're going to work backwards, you just have to plug in like a random choice and, you know, work it. But in problems where there is a too big, too small concept, then you can do this. Any questions about the working backward method, go ahead and post them in the box. If not, we'll look at an algebra solution. So, because again, flexibility in problem solving, we want different ways to do this. So, if you're doing algebra here, the median is 7 all the time. This is what makes algebra possible, by the way. I mean, one warning that I should give, it's not a warning that applies to this problem, but this is why algebra is possible here. Namely, the median is always exactly the same. Like on most median problems, algebra will not work because usually there's no algebraic expression for this. So on most algebra problems, on most median problems, you can't use algebra. Here you can, that's what makes this an anomaly. So Rajesh, interesting, because you don't wind up with integers, right? I mean, if you work backwards, I mean, you wind up with a mean of 49/6. So, I mean, you get lucky if your median is an integer, but I mean, the mean of these numbers is 8 and 1/6. That's not an integer. So that's yeah. Kyle's right about that. If you make that assumption, that can go horribly wrong. And I mean, you know, you should just don't try to be too smart. Just solve the problem that's in front of you. I mean, if you find a shortcut, it might be wrong. I mean, like one thing you don't really need on the GMAT is shortcuts. Because, I mean, folks, these are not long problems in the first place. So you don't need shortcuts. Because you're not really saving a lot of time anyway. I mean, you just work the problem. So if you're going to do algebra, the median is 7, and then the mean is the average of those 6 numbers. So the mean is the sum of all 6 divided by 6. So that is 4, 5, 6, 8, and 10 adds up to 33 plus x divided by 6. So then the way you would set the algebra equation up would just be this is the median is 6/7 of this. So 7 is the median. And then 6/7 of this. And then you would solve. So, and most people here are perfectly capable of algebra. So I think that we don't need to do that on the board. That way we can get to some critical reasoning stuff. Any questions, go ahead and throw them in the chat box. How can we get the mean? The mean is totally unchanged by that. I mean, the mean of these 6 numbers will always be this. If it's the median, you would just have to break it into cases. Like, let's just talk about that really quick. Can you have an algebraic expression for it anymore? Absolutely no, you cannot. So, like, let's say you just had, what were those numbers, 4, 5, 6, 8, 10, and x, where x could be any number, not necessarily increasing order. Well, then you would have to break it into 4 cases. like if you have case 1 is x is anything that is 5 or less. In this case, the median would be, in this case, the middle values are 5 and 6. So your median would be 5.5. Case 2, x is between 5 and 6. In this case, the middle values are, it would be 4, 5, x, 6, 8, 10. So x and 6. And so your median is x, whatever x plus 6 over 2 is. If x is 6, then in this case, the median is 6. I guess you're looking at 5 cases, not really 4. And then if x is between 6 and 8, then it's 4, 5, 6, x, 8, 10. So your middle values are x and 6 again. So it's the median is x plus 6 over 2. And then finally, if x was something that was more than 8, then in this case, your middle values are 6 and 8, as they are in the problem that you actually solved. So you would not be able to avoid breaking this into these cases. I mean, they might tell you additional information that would eliminate some of these cases. I mean, they might, right? But if they don't, you would absolutely have to think about all of these different possibilities. And, you know, there are problems that totally make you do that. Because, again, this is not hard math at all. It's like 3rd grade math. But you do have to be very organized in a way that's not 3rd grade. So that's the thing you'll realize about the GMAT. I mean, the math is not the hard part of the math. The hard part of the math is the organizing part of the math. So there you go. Okay, let's see if we can hit up some critical reasoning here. Remember that the theme that we're looking for there today is some passages containing statistics. We've definitely got some time to look at. You're welcome. We've got some time to look at least one such problem and maybe more than one. So depending on how time goes. So let's take a look and see what's going on here. How about this guy? So same deal with answer choices. Now it's a verbal item, but that doesn't change anything really. So that's where you find those. Here's a timer. Go for it. Okay, let's take a crack at this. If you, the usual comment at this point, if you haven't answered the problem, please do answer the problem. And yeah, because it's a test where you have to answer all the problems. So make sure that you do. So I'll give you another 10, 15 seconds or so to check that out. Okay, so let's take a look at what we're doing here. We do have a decently strong majority this time. Here's what people responded with. Or not, we don't want to do it that way. We have a lot of non-responders, though. We have like 12 people not answering the question, so that's not great. But of the people who did respond, people seem to like E. So what's going on here? Well, the point is, I mean, the theme that we're looking at here is when you have statistics cited in a passage. I mean, does anybody have any general insights into that before we start talking specifics? Like, if you see statistical information in a passage, where should your brain go with that? Like, where should you start rolling with that? We are advised to make our own assumption first. Advised by whom? I mean, I don't know that anyone gives that as blanket advice. I mean, if something jumps out at you as being clearly assumed in the argument, then you should have that in mind, you know. Like, if something is so obviously assumed that it just jumps out at you. But I wouldn't worry about trying to, I mean, if nothing immediately comes to mind, I wouldn't worry about trying to, like, formulate it. I wouldn't break your back to try to predict the answer. But I mean, as far as the general advice goes, I'm not sure where exactly that's coming from. Maybe you could tell me. But yeah, when you have statistics in these passages, the point is a very general point. The point is that you should pay attention to, like, why that particular choice of statistics. What does it account for and what does it not account for? So, like, when you see statistics in a GMAT question, a critical reasoning question, you shouldn't treat it like a quant problem. Like, if you treat it like a quant problem, that's just kind of a world of trouble, because it's not a quant problem. Like, you are not ever going to have to do elaborate calculations with statistics in a verbal problem. It is just not going to be a thing that happens. So, because it's the verbal section. I mean, there is the IR section, which is, you know, this new wave thing where they're trying to combine quant with verbal. But the verbal section is still, honestly, the verbal section. So they're not going to suddenly hide a, you know, mathematically intense doozy of a problem in there for you to discover and be horrified by. So, but what you should do is you should think about, you know, why would one choose this particular measure? And, like, what does it account for? And what doesn't it? Like, what doesn't it account for? Like, in other words, what are some other factors that could make it a bad or inappropriate measure for the task at hand? So this is what you should think about with all statistics. And that's what they're trying to get you to do. Like, if you're doing elaborate mathematical calculations, then you're really not going where you're supposed to be going here. So let's think about this, right? This is the hazardous waste output is 90 pounds per production worker. So yeah, right, it's Jeremy number 2. When you see pounds per production worker, the point is that it doesn't depend on how many workers are there. Like, this doesn't depend on the scale of the operation or a number of workers. And I mean, that's not necessarily a bad thing. It's just a thing. I mean, if you're talking about, you know, because it all depends on what your purpose is. And then that's why, I mean, that's why these questions don't include good, bad. Because it's not, you know, good guy, bad guy. Like, there are some situations where you would totally want to use pounds per production worker. And there are totally other situations where that would be a completely inappropriate measure. Like, for instance, if you're talking about how much pollution is released into the atmosphere and how much, how many gallons of stuff is out there damaging the environment, then you're totally not going to want measurements per worker, because that's not the point. The point would be how much total pounds of stuff escapes into the environment and gets into the cute animal's food. But if you're talking about, which operation is like a cleaner operation in general, then you would want a measure of per worker. Because, you can have an operation that is, smaller but much less clean, which would still produce less total poundage, but it would produce a lot more poundage of pollution, hazardous waste, whatever, per worker. So, I mean, the point is it's not a good, bad, black, white, yes, no kind of thing. But what you should be able to do is say, like, what are the advantages and the disadvantages of each of these statistical measures, and when would you use them and when would you not. And then, so what we've got here is a bunch of things about pounds per production worker. But then the problem is that's not what the goal of the manufacturer is stated in terms of. The manufacturer's goal is stated in terms of the total yearly amount of hazardous waste. So the red statistic does not account for the scale of this overall operation, but the thing is that the whatever color that is, turquoise, bluish, green sort of thing, does, like this measure, does depend on scale. Can you guys hear me? Yeah, that's better. Okay. Okay, well, here's the story. So, I think I'm still there. I'm getting a lot of yeses. You've got this discrepancy, and this is where they want you to go with statistical measures. They want you to be like, okay, I see why they're using the measure they're using, and you're specifically not dissolving your soul and heart in mathematics. You're just saying, here's what this statistic represents and what it doesn't. So if you have this sort of idea, yeah, I actually kind of am farther away now. So if I sound farther away, then that's what is going on. Anyways, so you've got this discrepancy between the scale of the operation and not the scale of the operation. And so we need a choice that has to do with the scale of the operation. And that would be this one. Because if you have a total, you have to assume there's not a big change in the number of workers. I mean, you can think about this the way that you think about assumption questions often, which is negating it, making it false. I mean, if you make E false, then you would have a big decrease in the number of workers. If that happened, then that would be trouble, because if you had a big decrease in the number of workers, then this number might jump just by virtue of a smaller denominator, right? If you have the same exact amount of pollution divided by a dramatically smaller number of workers, then your pounds of pollution per worker will go up, even though you don't really have any more pollution. So are there any questions about other choices here, why they are not what you want in this problem? Other choices? Any problems about those? Why is B wrong? Because the number of planes produced doesn't have anything to do with what we're measuring. I mean, it's just the amount of hazardous waste. So if you produce twice as many planes, then that's not going to, we don't know what that does. Like, they would have to tell you more stuff there. They would have to tell you that the amount of waste involved. You can't just assume that twice as many planes is twice as much waste. They would have to tell you that. Because maybe the waste is just from overhead or stuff that doesn't depend on planes. D, because we don't care about hours. We only care about pounds of hazardous waste versus pounds per worker. I mean, that's the thing with these questions, right? Some of you guys are asking about choices that contain measures that are very clearly unrelated to what we're talking about. So it's a focus issue to a certain extent here, right? Like, and I mean, someone was talking about predicting answers. I mean, it's not true that you have to actually predict an answer to the entire problem. But at least you should have a sense of what it is that you want. You should have some idea of what sort of concepts you want to see in an answer. Because, I mean, we don't, assumptions especially, assumptions don't introduce frivolous new ideas. Like, assumptions are things that are, like, necessarily built into the argument by the very nature of how the argument works. So we're talking about, you know, essentials. So, I mean, this argument is just about, okay, the pounds per worker had this decrease. And so, therefore, the total pounds must, or hadn't. So, therefore, the total pounds must have gone down, too. So if you're not, I mean, things that don't directly have to do with pounds per worker and pounds are just out of the question. They're not even things that you have to think about. So, like D, we don't care how many hours these people are working because we don't know how that relates to pounds of wastage per worker. Same thing with B, we don't care how many planes the factory makes. And then A, I mean, A says non-hazardous waste. So, I mean, maybe if you thought A, you were just not reading it very carefully. Because we don't care at all about non-hazardous waste in this problem. Like, the program is just about reducing hazardous waste. So, as soon as you see this word, you should be like, I don't care. This is not a thing I'm even worried about. How can I understand? Yokima, I don't really understand what you're asking me. It sounds like you don't want to introduce, maybe you're saying you don't want any more units that are not new units. I mean, again, maybe not, because it all depends, right? Like, if I give you a measure of, like, total crime, and then I give you a measure of crime per capita, then you would have to invoke the idea of total population to figure out what the relationship is. So there might be units that are not explicitly mentioned that are still roped in by the nature of other units. So, yeah. And then, again, Samantha, we actually addressed this point already, but we'll address it again in case you didn't hear. We don't know this. We don't have any idea whether this is true. Like, this is not a thing. Because, I mean, maybe the hazardous waste is just from the general operations of the factory, which don't, you know, even if it's turning out 0 planes, you still have to have machines that are up and running. So we don't know that. It's not a thing. And I mean, even if you think there is some sort of connection there, it's definitely not as solid as the connection between these things and E. Because, I mean, the number of workers is the direct mathematical link between pounds per worker and total pounds. And there's no question which is more closely related. Steve, how can you understand it easily? Just read the words, basically, and pay attention to them. I mean, you have a not and a false. So it's false that they have not met their goal. I mean, the best way for me to answer that question is to answer, like make it a conversation, make it a dialogue in your head with somebody. Because if somebody said that to you, I bet you would totally understand it. I bet you'd be like, it's false that they didn't meet their goal. You would instantly understand that they did meet their goal, or at least according to this person who was arguing, they met the goal. So, yeah. Okay. Sarah, we actually can't do the algebra for that problem at this point. I mean, that'd be number one, it would be sort of an awkward transition, but number two, we're out of time. So, if you that problem, I mean, the algebra is just here. It was this problem right there. Like, you just wind up with 7 equals 6/7 times that fraction. The 6's would go away, so you'd wind up with 7 equals 33 plus x over 7. If you don't understand how that works, then you might want to check like the Foundations of Math book or something where they talk about math with fractions and stuff. But we gotta close the curtains here just about now. So we're gonna keep doing statistical critical reasoning problems next time. So thank you guys, and if you have any quick, mostly administrative type questions, feel free. If not, we are gonna wrap it up. It's not next Thursday, it's every other Thursday. So with some breaks, but yeah, this is every other Thursday type of thing. The times, are you on EST? I mean, I think that means the program. I mean, I'm sure you don't care what time zone I'm personally on. I mean, the times on the website are all listed in Eastern, but they say that. I mean, it'll be listed. The time zone will be listed with the time. All right, we're going to kill the recording here.